All right, good morning, everyone. Welcome to today's class on machine learning. If you're joining me for the first time, I'm still welcome. So our today's class is going to be on machine learning. We've looked at various libraries in Python, ranging from NumPy to Pandas to Matplotlib to Seaborn. Now we will start with machine learning. Now we're looking at understanding how machine learning works, the pre-processing, the training, the modeling, the predicting, and evaluating. All right. So now, what is machine learning? If you, in human speaking or to a layman, if you ask what is machine learning, it will just tell you, okay, machine just learning something, or let's say a smartphone learning something, or a layman is just going to say it just the way the word is, machine learning, that is a device or an electronic device learning something. That's how a layman will put it. But as a data analyst or a data scientist, you have to put it in terms whereby when you explain it to someone who is a newbie in data science or a layman, the person will get the concept. Okay. So now, what is machine learning? We say machine learning is a method of data analysis that automates automatically modeling building. Now, these definitions might not sound um, complete. Okay. So now, for me, if I'm to explain machine learning, okay, I would say, okay, machine learning is the ability for um, for a machine to learn from, that is, learn previous data and pattern in the data and be able to make predictions. Okay. Now, machine learning was originated from artificial intelligence, which is AI, and now it uses some modeling and some algorithms to make predictions and forecast. Okay. So now looking at the second point, they said using algorithms that iteratively learn from data, machine learning allows computer to find hidden insight without being explicitly programmed where to look. Okay. So the whole idea of machine learning is just you feeding a model or an algorithm the data, and it will identify the pattern in the data. From there, it will be able to make predictions, or it's going to be able to find hidden pattern and find hidden insights from it. So here we said hidden insight equals to pattern in the data set. Okay. So now let me explain what this is saying. Let's say, for example, we have a supermarket data set ranging from 2010 to 2022. And for us, like looking at it, let's say we import this data set into Python, into Jupyter Notebook, and we try to do some visualization using Seaborn or using Seaborn or Matplotlib, and we identify that from 2010 to 2015, there was a decrease in flow of profits and transaction. Things were not going as smoothly. But in recent times, from 2016 to 2018, the sales and profits came up, and they were like the income rate, the profit rate in the supermarkets increased due to the kind of product they introduced into the supermarkets. Then in 2019, the between 2019 and 2020, the profits reduces. That is, their profit rate or income reduces. So that's the pattern. All I've been saying, from this so year to this so year, there was an increase in profits. From this so year to this so year, there has been a decrease in profits. That is a pattern. So now, as I'm telling you, I can just for human like me, I can just look at, okay, since it's 2010 to 2022, I'll be able to say, okay, this is the pattern. But imagine if it's a big data. Okay, imagine if it's a very large data that I can't, let's say from 1914 to 2022. Imagine that kind of data. How will I be able to make How will I be able to identify the pattern in that data set? That's where machine learning comes in. Okay. So now, what is machine learning used for? Machine learning is used for fraud detection, web search results, real-time ads on web pages, credit score and next best offers, prediction of equipment failure, new pricing model, network intrusion detection, recommendation engines, customer segmentation, text sentiment analysis, predicting customer churn, pattern and image recognition, email spam filtering, financial modeling. Now, all these listed are the things that machine learning could do. Now, let's take, for example, fraud detection. Machine learning model. There are models that have been integrated to let's say for example, email spam filtering. For example, if someone sends you an email, let's say someone trying to deceive you, or someone sending you a phishing email, that is a fake email, and you don't know if it's fake or legit, but there's a model that has been integrated to Gmail or any other email to be able to differentiate between a good email and a bad email. That is, it identifies some pattern. Okay, let's say, for example, that we all know that HTTPS means secure and HTTP means unsecure website. So if you receive an email and they are saying, okay, click on this link to join the community, and it's saying something like HTTP without the S, which means secure, the model will be able to differentiate that, okay, this is HTTP means non-secure, while HTTPS means secure. So that's where it's used. Now, predicting customer churn, that is, you could predict the next sales for the next 5 years or the next 2 years based on previous pattern, okay? So what machine learning works with is the data given. It just basically identifies hidden pattern in the data, and it's trying to make prediction or forecast based on the data. Then we have different network intrusion detection. Now, if you are familiar with antivirus has machine learning in them in such a way that they have been able to identify various applications or various software that have malicious that have malware in them. Okay, so that's where network intrusion detection comes in. Or you are in a network, there are models that have been integrated to networks or to a router or a firewall in such a way that once you are connected to it, let's say you are trying to access a website, to tell you you can't access this website because this website is malicious. Okay, so like what web search results also, you want to search for a result, it gives you let's say, for example, you want to search something on Google, it gives you like you just type how, it auto suggests for you some things that's based on your previous research. It's trying to suggest basically probably this is what you're trying to say. So like, for example, Google is linked. Okay, if you search for something on YouTube, you search something on Google, you search something on your on your Gmail, and you're trying to search something, or your social media, and you're trying to search for something now on let's say Instagram, you are likely to get a suggestion from what you search from probably Facebook or Twitter. So that's how it works. Now let's look at the types of machine learning. Now, machine learning is divided into three, just three basically: supervised, unsupervised, and reinforced learning. Now, for the supervised learning, it works with categorical data. Okay, it works with categorical data. That is, like, for example, we have fraud detection, email spam detection, diagnosis, image classification. Now, have we noticed in such a way that if you put, I don't know if you are familiar with image recognition, how most times when you have, if you have smartphones that requires you to use your face to unlock your phone, in some cases, right, once you put the face, your phone in front of your face, it's literally just unlock your system. Now, I'm very sure when you're trying to set up that kind of feature to use your face to unlock your phone, you must have put in different face, different images of your face in it. That is, they might ask you to turn your the left side of your cheek, or the right side of your cheek, or the face of your cheek, and or you should place your face in a circle. I don't know if you've noticed that. So they are trying to get different images, different facial expression from your face in such a way that once you put in your face, to be able to recognize that, okay, this is you. It's now grants you access. Just like voice recognition also. If you put in, if you use a voice, if you use smartphones that allow voice recognition to unlock phone, okay. So once you have to put in various voice, let's say voice that you. So imagine you have running nose, or your voice is not clear, and you try to unlock your phone, you won't be able to do it because the voice doesn't match with the one you've recorded. So that's where classification comes in. Or we're trying to identify images of, let's say, brain tumor in a patient. Okay. Now, machine learning requires data, as I've said earlier. Enough data will help the model to identify a pattern in an image or in a data set. So, for example, let's say, for example, I need to identify three animals, or let's talk about okay, three, or let's talk about just two animals, a dog and a cat. Okay, and if I have, okay, let me use this example. I have, let's talk about just one animal, a dog. Now we have different breeds of dogs, right? We have German Shepherd, we have puppy. Let me just use those two because I'm not a dog person. But we have German Shepherd, a family of German Shepherd, and we have puppy dogs. Okay. Now, how do we differentiate between a German Shepherd and a puppy dog? Now, you know, a German Shepherd and a puppy dog have different characteristics. They have the one of the hair, the body type, the weight, the facial, the look, the body color, the ear type, and the rest. So how do we differentiate between a puppy dog and a German Shepherd? Okay, so now we need to feed a machine learning model with different images of a German Shepherd and of a puppy dog. So let's say we have like 20 images of a German Shepherd, 20 images of a puppy dog. Okay, now these images are what we classify as data. You know, data could be either image, video, picture, text. Data is not just only text alone. Data could be images, it could be voice, it could be sounds, it could be, that's everything about this. So data, you could research more on data. So we have, as I was saying earlier, we have classification, which is under supervised learning. So that one has to do with different data based on image. Then we have unsupervised learning, which is dimensionality reduction. Now, text mining, facial recognition, big data visualization, image recognition. I'm going to explain later more on this. Okay, then we have reinforcement learning. So in most cases, reinforcement learning is like having a toddler, like a baby, learning a language from the parent. Okay, I know when we are growing up, it's not as if someone taught us our native language. We learned it from our parents, like that is our parents, while they speak, we learn it from them. So that's more of like reinforcement learning. Okay, so the machine or the algorithm, sorry, the algorithm or the model is going to learn based on the data fed on it, or rather than learning from the data fed on, it's going to generate, or it's going to learn by itself. Okay, then we have regression, we have clustering. Now, all this we're going to explain in the next slide. But before we explain, I have a series of pictures I'm going to use to explain that. But let me explain the machine learning process. Okay. Now, for machine learning process, we have 1, 2, 3, 4, 5, 6. We have 6 phases. Okay. Now, the first phase is data acquisition. That is, you acquire the data. Okay. Or let's talk about data gathering. You can call it data gathering. So now this process requires you to gather your data. That is, okay, what kind of machine learning do I want to do? What kind of data set do I want to use? Am I talking about an image recognition? Am I talking about a text recognition? Am I talking about predicting text? Am I talking about predicting numbers? After acquiring your data, okay, so now let me use an example of this. So for data acquisition or data gathering, we are working with a supermarket data set. Okay, as I've said earlier, from 2010 to 2022. That's our data we are using. So just have this example at the back of your mind. Now, for data cleaning, which is the next phase, right? For data cleaning, what is expected of us is to clean the data, because machine learning solely rely on clean data. Okay, you cannot do a machine learning with a missing data. Now, what I mean by missing data, incomplete data. For example, you have like 20 rows of data missing, or some values or some space are missing in your data set. Let's say, for example, a column was not properly filled, or a box was not properly checked, or there's something missing in your data set. Machine learning will not be able to work with that. So it's good to have, if not 99.9 clean data before you can move to the next place. So now we've been talking about an example called the supermarket data set from 2010 to 2022. Now we have to clean this data as much as possible. There are methods of handling missing data, so you could research on them, but I'm going to give us some. So there's the method of handling missing data includes dropping the missing data. So now you drop. When I mean drop, I mean delete. We've talked about it in pandas. Okay. So when I mean drop, I mean delete. So if you have a data set that is, let's say, 10% missing, or 10% missing data sets, which are irrelevant to your data, that is to the objective of what you want to do, you can decide to delete them or drop them. Okay. So let's say, for example, I have like 10 rows out of 200 rows. I have 10 rows out of 200 rows missing data. Because I have 200 rows, which is large enough, I could drop the 10 rows. Okay. But let's say I have just 20 rows of data for my supermarket, from my supermarket store data set, and I have 20 rows of data and have 10 missing value. There's no way I'm going to drop the 10, because if I drop the 10 missing value, I'm left with just 10 rows of data sets to work with, which is not enough, because you need a lot of rows of data so that the machine learning model will be able to identify the pattern in the data set. I hope we're getting it. Okay. So now the next thing after you cleaned and pre-process your data is to do what is called model training and building. Okay, model training and building. So at this phase, you have to select what kind of model best suits the kind of prediction or the kind of machine learning you want to work with. Okay. Now I'm going to go back to the types of machine learning models we have, but let me just explain this process. So after identifying the models, that is, are you going to work, because we have series of machine learning models. We have linear regression, we have k-nearest neighbor, we have logistics, we have scientific learn, we have tons of them. There are different machine learning models. Okay, that the different machine learning models. But for this class, we're going to work with linear regression only, and probably logistic regression. Okay, the logistic regression is going to be our project. Okay, so now moving on, we have model training and building. Now we said we are working with 200 rows of data set, right? Now for a supermarket. Now the next thing to do is to split the data, okay, into test and training. Okay, you split your data into test and training. Now the training always take like 80%, while the testing data set always take like 20%. Okay, I'm going to explain it later when we are doing the labs. That's when we are trying to run through our Jupyter Notebook. Okay, so the first step is acquiring the data. The next step is cleaning the data. The next step, that's step 3, is to identify the model you want to use. Is this data set a classification data set? Is it a supervised or unsupervised learning, machine learning model am I going to use for it? So so after that, okay, for step 3, you identify the model. Then step 4, you split the data into training or into training or testing data sets. So after splitting your data into 80 and 20%, which makes it 100, now you test your model. Testing of model is just like comparing the predicted model with the testing model. Now, all you will use to train the model is your training data set. Okay, you train your model with a training data set. Then the testing data set, don't forget I told us we're going to split our data into testing and we're going to split our data set into testing and training data set. The testing is going to take 20%, while the training will take 80%, which is equals to 100%. Okay, now for the 80%, that's what we are going to use to train the data set, the model of that is the machine learning model. We use 80% to train the machine learning model to other predict. So let's say, for example, we predicted something. Okay, let's say we predicted a colon in the data set. Then we now use the 20% of the data set to validate, that is to compare with the predicted the testing data set compare with the predicted data set. So that's where model testing comes in. Then after that, we now do model deployment. That is, model deployment involves integration. Okay, now you do model deployment by integrating it with a web application or a website. Okay, you could integrate it to a web application or a website, either way. Okay, or a mobile app. Yeah, you could do that also. So moving on, we have types of machine learning. Okay, now let me explain. So we have supervised learning, unsupervised learning, and reinforcement learning. For supervised learning, you have label data and are trying to predict a label based off of known features. Okay, for supervised learning, so for this class, we'll be working with supervised learning. So for supervised learning, it has label data in the sense that we have our X variable and our Y variable. I'm going to explain the next slide what X variable and Y variable means. We just know we have X variable and Y variable. Now, we are working with label data, which is X variable and Y data, and we are trying to predict a label based of known feature. So let's say, for example, in a data set, we have column A. Hope you know column R is the vertical row and vertical. So we have column A, column B, column C, column D. Okay. So now take, for example, A, B, C. Okay. Column A, B, C is our Y variable, and column D alone is our X variable. So what we want to predict is our X variable, which is column D alone. That's what we want to predict, column D alone. So how do we go about it? That's why they say trying to predict a label based of known feature. So the feature we want to predict is column D. Okay, so that's just a quick example of supervised learning. Unsupervised are unlabeled data and are trying to group together similar data points based on features. Okay, so for unsupervised learning, the data are just cluster data. That is, they are ungrouped. So you just make prediction based on the data you have. You try to group them together and make it. So, for example, let's say we want to identify if this animal is a cat or a dog. Okay, then we now feed with different images of a cat. What are the characteristics of a cat? A cat has ears, their eyes, their nose, the air they have, their mouth, and the shape of their face. Now we have a dog. A dog has the shape of their face. They have the eyes, the nose, the hair, so, and the shape of their head. So now, how do you now differentiate? So the moment the model sees that, okay, this image and this image are kind of alike, this image and this image are kind of alike, it's able to say, oh, this is a dog, this is a cat. Okay. Now, the reinforcement learning algorithm learns from performing an action from experience. Okay. That's why I was trying to explain to us that as a child, when we're growing up, we learn from the experience of our parents. Okay. We learn how they do things. Let's say how they talk in our native language, how they communicate, how they greet people. So that's why you see most little children, they try to emulate the characteristics or the things they learned from their parents. Okay, so you learn is an algorithm that perform an action from experience. That is the experience gained from another person. So we'll be looking at that soon. So now let's look at the different machine learning. Okay. Now we've talked about the two types of and three types of machine learning. We say we have supervised learning, unsupervised learning, then with reinforcement learning. Now we say our focus for this class is going to be on supervised learning. Now for supervised learning, we have classification and regression. Okay, so for classification, these are the models they use. When I mean models, I still mean the same thing as algorithms. So when I say models, I'm still saying algorithms. So we have support vector machines. Yeah, so these are the algorithms I was talking about. We have discriminant analysis, naive, Bayes. We have nearest neighbor. We have neural network. So neural network is a popular CNN. We have RNN too also. So neural network, you could research more on them. So this classification. Now, let's say you want to identify an image, a voice, a sound, sounds. You want to identify pictures, image, sound. This is word classification because they are classified. Now, regression has to do with numbers, okay, continuous or continuous variables. Let's say you want to identify, you want to predict the customer's the profit you are likely to have next year. Let's say, for example, you have a data set of for 5 years. Let's say from 2016 or no 2017 to 2022, right? From 2017 to 2022, you have a data set for a customer for a supermarket. How do you want to know the profit in 2023? So that's where you can now use this kind of algorithm. So that's why we're using regression. So most times we work with linear regression, JLM, support vector machine. We have embed assemble, sorry. Then we have decision tree, we have neural networks. Then we have clustering. Now for the unsupervised learning, I was talking about clustering. That's where we have all these models also. So now let's talk about choosing an algorithm. So if you want to classify an algorithm, if you want to do classification, you choose from this aspect, that is the classification models. If you want to work with regression, you choose from here. If you want to work with so now there's a library called scientific kit-learn. Now this algorithm is what is mostly used with this also called this TensorFlow also. These are advanced machine learning. Okay, so all these libraries are what we use. This scientific kit-learn is a library we use for prediction. In fact, it has series of models that can be used with it. Okay, so you could read more on scientific kit-learn. Also, there's a cheat for it, a cheat sheet for it. Now, scientific kit-learn package is the most popular machine learning package for Python and has a lot of algorithms built in it. Okay, every algorithm exposed scientific kit-learn via an estimator. First, you will import the model from general. So this is how to import model. We'll be looking at it soon. So from scientific kit-learn, you could import linear regression. You can import support vector machine. It's different this thing. So now let's talk about data understanding. I've talked about cleanliness. So the first thing I thought was machine learning is worked with the clean data. So now machine learning is just one end to the game. How well your model performs is highly dependent on your data. So I told us data is the end goal. The larger our data set, the larger and clean our data set, the more the machine learning model will be able to identify the pattern in it and will be able to give us a good accuracy. So we have outliers. Outliers are things that are outside the description of what we are working with. Okay, let's say for example, we sent out a form and we expect people between the age of 20 to 40 to fill, and somebody of 100 is filling our form, that age 100 is an outlier. That is, it's not supposed to be part of what we are trying to, or what we are looking for. Then distribution, we could use visualization to see the distribution of our data sets. That is how our data sets evenly distributed. That is, when we're doing the training and testing, are they evenly distributed? Then the question you have to ask yourself is, can the data answer the question? Most people, they just find data and start working on it just like that. There are questions you have to ask your data, because the whole essence of data analysis or data machine learning or data prediction is to answer some questions for the top management to be able to make decisions. Okay, so once they see the prediction or the visualization, they should be able to make decisions with it. Okay, now for machine learning, we have Y label and X label. So I was telling us earlier on that we have X and Y. So our Y label are called the dependent variable, while X are independent variable. So what do I mean by dependent variable? I mean dependent variable are variables that depend on other variables. Okay, for example, if you are to buy a house in a specific location, okay, now you have to consider some things, such as how many bedroom flats it is, the location, the population of that area, what do people say about that area? Are people comment about that area good? What's the criminal record of that area? What are kind of people that stay in that area? So these are like the dependent factors. Okay, so all these are just mentioned as dependent variable. Why X? Now let's say X is the price. You know, for you to buy a house in a building. I'm sorry, to buy a building or a house in a specific location, you have to consider something. And because you are paying a price, which is your independent variable, X. X is your independent variable. That is, you are trying to, okay, sorry, I'm sorry. X is your independent variable. Okay, that is all your, sorry, let me come again. Y is our dependent variable, which is the price. Okay, price. I'm sorry, I made a mistake. So Y is our dependent variable, which is the price. The price of a house will determine. So the price of a house will determine whether you get it or not. And for you to even say, okay, let me consider buying this house, it depends on some factors, which is our X variable, the independent variable. Okay, like what is the how many bedroom flats is the house? What is the age of the house? When was it built? What's the population of the area? What's the location of the area? What do people say about the area? What's the criminal record in the area? So all these things I've mentioned are independent. They don't depend on anything. Okay, they are standalone. The population of the area, population of the area, or the population of a community where you want to go and buy your house can stand alone. It's not depending on anything. But price depends on all this stuff. So if I know that, okay, the house of this, the age of this house is like 20 years or 100 and something years, I can decide to say, wow, and it's still as beautiful as this, I'm going to double the price. Or I can say, wow, I don't think I can what's it called? Because I have to make some amendments to this house. I don't think I can buy it. So I'm going to, instead of buying it for 1 million, I can buy it for 200,000, give or take. The person is going to agree or not. Okay. So now I was saying something about splitting of data into training and testing. Okay. So now let's look at this data. For example, data equals to 120450. Okay. So the first set of data is 120. The second set is 450. What we've done for the first set and second set is to split the data. Now we say the first set X string. Don't forget X is independent. That is, it is not depending on anything. It's 1, 0. No, sorry, 1,2. Then the first set of white train, that is our dependent variable, is 0. That's what we want to predict. Okay, what we want to predict. Then the second set, x test, is 4, 5, and y test is 0. So what we want to predict is y. Okay, we want to predict this value y, which is our dependent variable, which is the price. Okay, but for our x variable, we are not predicting, we are not what's it called, predicting, we are training the model. So depending on what model we decide to pick on. Okay, so why train and test on a subset of our data? For evaluation, split model, then fit the model. Okay, then the accuracy or the accuracy that you get when after predicting is what will determine if the model you use is right for it or not. So predict on the trained model class, test against known values, reevaluate our model, repeat the whole process to optimize for time, accuracy, and generalization. Okay, so if you predict after prediction and you check for accuracy, there are models we use for accuracy. We have the F score and the I think recall. I'm not sure. I think that is under SK-learn. Okay, we're going to look at them soon. Okay, now machine learning is not what is what machine learning is and what is not. So machine learning is a tool. Machine learning is highly dependent on quality data, as I've said earlier. If your data is not clean, properly cleaned, and properly enough, it won't be able to solve the problem. Now, machine learning does not solve all problems. That's true. Machine learning does not solve. A lot of people think, oh, machine learning will solve all the problems. No, machine learning does not solve all the problems. Okay, and they say machine learning is one approach to solving data uncertainty issue. Yes, that's true. So, for example, I could have a data set and I could just visualize with the data set, and that's all. Okay, that's probably what is enough for the management or the board of directors to make decisions. But if I want to do in such a way that, okay, I want you guys, I'm going to do a prediction, at least the price or the profit prediction of what profit I would likely to earn for the next 3 years. Okay, so I want the board of directors to take their decision higher to the next level. I could do machine learning. I could do prediction. So when I predict for them that, okay, in 2023, 2024, 2025, these are likely the price and the profits we are going to make from this and this. So if we put in this effort and this effort, we are going to have this effort and effort. If we fix in the weakness of this stuff, we are going to have a great sale or a great profit at the end of these 3 years. Okay, so the next point 5 is that machine learning will not always get it right. That's true. Machine learning will not always get it right. Even if you use the right model or the right, even if you have the right model or the right algorithm. I told you model and algorithm are the same thing. Machine learning will not always get it right. Now, results from machine learning are to be backed up with domain knowledge and experience. Okay, so if you don't have experience in machine learning, I require you to read more if you want to advance in machine learning, because machine learning is very broad. It's just a branch of AI, artificial intelligence, but so learning works with models. You just have to use a data set along with a model that best suits whatever you want to work with. Okay, so now that's all for this one. So I have a documentation here that contains everything about understanding machine learning. I for my research and read ups from textbooks and websites, I came up with all this. So for supervised to predict a future, unsupervised discover structure in the data. Okay, so you could read more on this notes. Okay, so there's something called overfitting also, or called when you fit a model too closely to particularities of the training set and obtain a model that works well on the training set but is not able to generalize the new data set. Okay, so for example, let's say you fit in a data set. Okay, you work with the data set and a model, and you now updated the data set. Okay, and the data set is unable to fit into the new data set. Okay, that would be an issue. All right, so you could walk through this this PDF that I have here for those that want to do more reading. There are YouTube links that you could work with also. So you could scan through this and do some read-ups also on them. Okay. So let me share some images here with us. So these are some images. I've showed us this one. So for this one, okay, I've shown this, I've shown this, I've shown this. So for example, I told us we have supervised, unsupervised. Okay, there's also semi-supervised learning. We have reinforcement learning also. Then we have continuous target variable, categorical variable. So regression and classification, can you see? So it's basically working with price. These are now medical images. So let's say you have brain tumor or cancer images you want to do work with this, or you want to predict a house or a supermarket. So you see for supervised learning, we have the target variable not available. So we don't know what we want to even predict, but we know that, okay, we are predicting something, we're looking for something. These guys, they always have the target variable, which is the Y variable, that is the dependent variable, as I've said earlier. So we have customer segmentation, market pocket analysis, then we have semi-supervised. I said 4 initially, but most people just look at just these 3, supervised, unsupervised, and reinforcement learning, but we have semi-supervised also. Okay, then we have, okay, so if you want to okay, I've talked about this. Okay, so I've talked about literally everything. So all these are the difference between X variable and Y variable when we split our data set. So we'll be working with some visualization, some labs soon on them. So where we look at splitting and training. So see us in the next class where we do an elaborate work using logic regression. I'm sorry, linear regression. Sorry. Thank you very much and have a blessed day.